Section 1.16 talks about us continuously considering continuity. So what does it mean for a function to be continuous at a point? So this involves three parts, and I'm going to try to illustrate this while I explain it at the same time. So really try to get at the concept of this, because we'll work through this pretty easily. So, for a function f to be continuous at a point C, the following must all be true. Okay, so we're picking any point. We're just picking some arbitrary point C, and we're going to go through the process of how all of the things that must be true in order for that to happen. And so we'll talk about the situations where it doesn't work as well. And so we think about the combinations of things that can happen. Okay? So our first option, the first thing that must be true in order for a function to be continuous, and again, remember there's three, is that f of c must exist. Okay? So if we think about what that means, is that on somewhere in our graph, we don't know where C is, but let's call this C. We have to have a filled in dot. There has to be a value of that function at that place. Okay? So that has to be true first and foremost. Now, we further expand upon that as we move along, but it has to have a value there. So anything outside of the function's normal domain can't work, right? It's not going to be continuous. Number two, the limit as x approaches c of f of x must exist. So think about what that means. So if the limit has to exist, then that means when we approach some number c, we have to have the function approaching the same place. Okay? So when we think about that, that means that from one side and from the other, they have to be going to the same place. Okay? If they're going to different values, or if that limit doesn't exist, either it's infinite or they don't match on side to side, then we're not going to have continuity there. And our last part is that f of c must equal the limit as x approaches c of f of x. So what this means for us is that not only do we have to have a value of f of c, but our limit of our function has to approach that exact same value. So all of these things must be in place in order for that to happen. Now, so when we have no continuity, let's think about our three things that we need. So the first thing, we need the limit as x approaches c of f of x to exist. The second one, again, we need, I'm sorry, I mixed up the order. We needed f of c to exist. And 3, we need the limit as x approaches c of f of x to equal f of c. Sorry, I messed that order up for you guys. So how could we do this without having some of the other things? So obviously, if we don't fit any of these, if this is not checked off, if the point doesn't exist at all, so for example, if there is a if at C we have a hole, right? We don't have any values of C, then we can't be continuous, right? We're not allowed to be continuous. So that point, so that's something that needs to happen. Now, what if the limit exists? So the limit exists. Okay, the limit exists at that place right there, but our function value is down here. So we can have both of these happen, but if they don't agree at the same place, then we're not going to have continuity, right? Because we're missing that point. Now, this is really what it comes down to. Oh, we're really looking. Wow, come on. We're really looking for that to exist. If for some reason that doesn't happen, they go to different places, or the function doesn't exist at a place, then we're not going to have continuity. So just having the value isn't good enough, but the limit has to approach the same place.